Now I'm going to introduce one new thing into this. Instead of x minus h plus k, I'm going to put a bx minus h plus k. And right now I'm just going to focus on y equals absolute value of bx. So you can see that the b, just like the h, is inside the function. It's inside the parent function. It's inside the absolute value function. So what's this going to do? First I'm going to start with my parent function. There's my parent function. Parent function is y equals absolute value of x. And I'm going to deal with this specific function, y equals 2 absolute value of 2x. So the 2 is now inside the function. It's not outside like the a. It's inside right there. It is a b. And we're going to isolate just this one part. So like we did with the h, I want you to think about what x value do I need to get a particular y value? Well, let's say that I want to find out what x values I need to put in to get the y value of 2. So I know that my function is 2, absolute value of 2x. Well, what x am I going to have to drop into the function machine to go through this cycle so that I wind up with an answer of y equals 2? Well, again, I can just look at it and I can see, well, if I drop in the value 1, well, that's going to kind of go in here. That's my x. I'll multiply it by 2. I'll take the absolute value of that, and I'll get my y equals 2. So at x equals 1, y equals 2. And I can see that would also work for negative 1. Because negative 1 dropped into this machine. Negative 1 times 2 is negative 2, but I am taking the absolute value of that. So negative 2, the absolute value of negative 2, is also y equals 2. So at negative 1, my y is also equal to 2. What if I want to have a y value of 3? What number do I need to put into as x to get a y value of 3? Well, as I look at it, I need to put in x equals 3 halves, because I dropped 3 halves into the function machine. 2 times 3 halves is equal to 3, and the absolute value of 3 is equal to 3. So at x equals 3 halves, right here, I would have the value of 3. And that's going to work also for negative 3 halves, because putting in negative 3 halves, 2 times negative 3 halves, is equal to negative 3, but the absolute value of negative 3 is also equal to 3. So at 3, I get 3 halves. At 3 halves, I get 3. What about if I want a y value of 0? Well, my x value, if I want my y value to be 0, is also going to have to be 0. Because 0 going into this absolute value function here, 2 times 0 is 0, and the absolute value of 0 is 0. So I would have x equals 0, y equals 0. And you can see my graph is going to look like this. Now I know this looks a little bit like, in fact it looks a lot like, if my function was 2 times the absolute value of x. And in some ways this one might be very similar. It's a little bit different. I would have to show you in a little bit more extensive way. But what this is doing when I have a b and it is inside the function, instead of making a vertical stretch like an A, it makes a horizontal stretch or compression. And what's happening is that my parent function, the x values of my parent function, change. I keep the same y values, but for the same y values, my x values change by 1 over b. So you can see in this example here, my x value was 2, my b was 2, so I took 1 over b, 2, times 2, and I got my new x value of 1. I took my x value of 3, and I had a y value of 3. My x value changed from 3 to 1 over b, 1 over 2 times 3 equals 3/2. So it is a horizontal stretch, a horizontal compression. Now, what do you think is going to happen if I change my function, instead of being y equals the absolute value of 2x, I'm going to make it the absolute value of 1/3 x. Well, a similar thing is going to happen. Again, I want to get a certain y value. Let's say the y value I want is 1. Well, what value do I need to put into the function machine to get a y value of 1 when my function is 1/3 the absolute value of x? Well, pretty clearly, I need to put in x equals 3, because 1/3 times 3 is equal to 1, and the absolute value of 1 is equal to 1. So where x equals 3, my y value is now going to equal 1. And that will be true also, as I'm sure you can tell, for -3. If I want a y value of 2, what number has to go in for x to make this work? Well, it looks to me like x would have to be equal to 6, because the absolute value of 1/3 times 6 is the absolute value of 2. So my y is going to equal 2. So at 6, my y is going to equal 2. And that will be true also for -6. So my graph now with a b that is a fraction is horizontally stretched. And it's stretched by 1 over b. 1 over 1/3, which is the same thing as 3. So all of my x values before, and my parent function, let's see if we can look at the parent function. The parent function, I had 1, 1. Now, if I have 1/3 x, my y will stay the same 1, but my x has to be 3 times as large. I have horizontally stretched this out by a factor of 3. So the b does horizontal stretches and compresses by a factor of 1 over b.